So let's look at this question here, which is on probability. Let's see how we can do this proficiently. So for the events A and B, given that PA is actually given by 0.7. So this question was taken from the year 2010, paper 2, question 7 of the A-level paper. Okay, so 0.6, and PA intersect B prime is actually 0.8. Find PA intersect B. I think that's pretty okay. PA intersect B, we can just use formula. That's basically we are given PA, given B, B prime happens. So this is PA intersect B prime over PB prime. So this case here, we will have 0.8 times PB prime. Maybe I'll just put this as a PA intersect B prime over 1 minus 0.6. And basically this is PA given PB prime happens. So this is 0.8 times 1 minus 0.6. That will be 0.32. Okay, so that's how we do the first one. Let's look at the subsequent part, PA union B. Part 2. PA union B would just be PA plus PB minus of PA intersect B. Okay, so that's what we need to find. So I think that's pretty okay. We already have A and B. Oh, but what I would suggest is also to just draw the Venn diagram out, because now we just need PA intersect union B. If you have A, you have this 0.32 here, which is A intersect B prime, which is this crescent here. This is 0.32, right? So PA union B could be simply just PA union B would just be 0.32 plus PB, which is actually just 0.6 here. Okay, so just remember to just draw the Venn diagram, and it should be quite fast. Subsequently, part 3, we are told to find PB prime given A already happened. So part 3, we will have PB prime given A already happened. So this is PB prime intersect A over PA. We are just going to use PA. Where's our PA? 0.7. 0.7. And PB prime intersect A will just be 0.32. So I think this is just using a formula. So 0.32 divided 0.7, that will be 16 over 35. Okay, there you go. So look at the subsequent one, part 4. That's a fun one. So for the event that PC is 0.5 and you're told that A and C are independent, okay, find PA prime intersect C. So if they're independent, meaning PA prime intersect C will be PA prime multiplied with PC. Okay, just remember that. If they're independent, you can just use whatever intersection between A and C will just be the individual events just multiply each other. Okay, so A prime would be 1 minus 0.7. PC would just be 0.5. Okay, then this will be 0.15. Okay, 0.15. That's about it. Let's look at part 5. Hence state inequality, stating state inequality by PA prime intersect B prime. Okay, so the first thing I would suggest is essentially draw out the diagram, because if not, you wouldn't know what's going on here. I'm going to start with drawing A and B first, which we already did. So A and B is here. So this case here, this is A and this is B. So this area here is actually 32%, so 0.32. And if I want to find A intersect B, okay, let me see. Okay, so now I draw out the C, but A union B is actually, A union B is 0.92. So outside here will be 0.08. Okay, because A union B is 0.92, I just take 1 minus 0.92 here. Okay, so outside here is 0.08. Just take note of that. Then after it, C comes into play. Now C is actually independent. So A prime intersect C. A prime intersect C is this crescent here. We are told that this crescent here is actually we found, right, this crescent here is actually 0.15. Okay, so the question now is, what is the inequality satisfy A prime intersect B prime intersect A prime intersect B intersect C will be here. This portion here. This half pillar potato here. Okay. Now, so what we're gonna do is actually very simple. We're gonna move this in and out because now you see the relationship between A and C is fixed. B, these two are fixed. This is also fixed. So basically this is fixed. This is also fixed. Okay. What is moving is between B and C. So this C here, C can actually move all the way in and out of the equation here. So that's why we know that we could swing in and out. So what I need now is this crescent value here, this value here. Okay, I need this value here. I'm going to find this value here. This value would be B intersect A prime. B intersect A prime. Where's my B intersect A prime? Will be B intersect A prime will just be A union B, PA union B minus PA. That will be 0.92 minus A, which is actually 0.7. So this is actually 0.32. 22. Okay, 0.22. So this is 0.22 here. So we move all the way in. Okay, great. So what we're gonna do next is actually just going to move A and B here. Then we're gonna move C here. Okay. So this is 0.22. Because this is 0.22, meaning this whole crescent here can move all the way in. So this is when C is here. So this is when case 1. This is A and B and C. Case 1 is when C A prime intersect C is subset of B. So that case here will be P A prime intersect B intersect C would just be 0.15. Okay, because this whole thing is 0.5. This 0.22 can accommodate 0.15. Okay. Case number 2 is when you think about it, right? What we need is actually A and B, and we need them to be exhaustive. So we need to exhaust every single resources we can. So outside is 0. So here will be 0.08. But because outside is 0.08, we can, and this whole crescent here is 0.15, 15%. You can only accommodate 0.0. You can't move all the way out. You can only contain 0.08 here. So this would be 0.15 minus 0.08. Okay. So this is case 2 when A, B, and C are exhaustive. Okay, so this case here, PA prime would be 0.15 minus 0.08, which is actually 0.07. So the inequality which satisfies PA prime intersect B intersect C will just be 0.07 here, and maximally will just be 0.15. Okay, so that's how we do this question here proficiently. And now any question or comments at all, please let us know. Keep practicing and I'll see you in the next question.